In this video, you will learn about scientific notation. What is scientific notation? It is a way of writing very, very large numbers, like the distance to the sun, or very small numbers, like the weight of a cell. The purpose of writing something in scientific notation is to eliminate repetitive zeros that make the numbers really, really, really long. So in order for a number to be in scientific notation, there are a few things that have to be true. The first number in scientific notation, which I have down here in orange, has to fulfill these requirements. It has to be a number that is greater than or equal to 1, but less than 10. So basically, we want a number that has a single digit in front, and then it can have multiple decimal places after it, as you see in these other examples, but it doesn't have to. So we just want to make sure that in front of the decimal there is only a single digit and it can't be 0. So greater than or equal to 1 but less than 10. And then it's always going to be times 10 to a power. That power can be a positive whole number or a negative whole number, which is considered an integer. We have not yet seen negative exponents, so I will explain what that means in a minute. You may have seen this pop up on your calculators at times. A lot of calculators don't show it like this. They, instead of the times 10, they replace that with the letter E, which in math represents times 10 or base 10. So first, let's just see if these numbers are or are not in scientific notation. Does this follow the rules for being in scientific notation? This one does, because this number is greater than or equal to 1 but less than 10 times 10 to a power. This one does as well, because this number is greater than or equal to 1 but less than 10 times 10 to a power. This one does not, because this number is greater than 10. This number also does not, because it is less than 1. And lastly, this one does not, because it is times 100 to a power, and we only use 10 for scientific notation. First, we're going to look at how do I take a number from scientific notation and put it into its standard form of a number. If the power is positive, that tells you how many times you are multiplying the original number by 10. If you recall that when you multiply a number by 10, it adds another place value to the right, then you can use the shortcut where the power will tell you how many spaces the decimal will move to the right. So let me show you a couple examples. Here we have 6.3 times 10 to the 10th power. So what that means is you're multiplying 6.3 by 10 10 times. That would look like this if we did it out by hand. As you can see, that is quite a lot of work. And if you type it into your calculator, because it is such a large number, the chances of you getting this result right back is pretty high. So instead of doing all this out by hand, if you think about what happens when you multiply 6.3 by 10, 6.3 times 10 is 63. So essentially, what happened is that this decimal moved over to the right one space and is now behind the 3. When I multiply it by 10 again, it will become 630, which again took that decimal and moved it to the right another space. If I know that, then I can skip this step of multiplying by 10 over and over and over again and move the decimal 10 spaces to the right. That would look like this. 5, 6, 7, 8, 9, 10. Our decimal ends up at the end here, which in a whole number we know we don't really need to write. We fill in all the empty spaces with zeros for a final answer of 63 billion. Here's another example, 1.45 times 10 to the 7th power. That would look like that. Or I can take the shortcut of moving the decimal 7 spaces to the right and getting an answer that looks like this, 14,500,000. One thing you want to be careful of is what it does not mean is that you're just adding 7 zeros. If you notice here, I only have 5 extra zeros at the end because my first 2 of the 7 place values were already filled with a 4 and a 5. Now, if the power is negative, what this means is not that it's a negative number. However, it means that instead of multiplying by 10, you're dividing by 10 over and over again. And when you divide by 10, that decimal gets moved to the left each time. So for example, 6.3 times 10 to the negative 10th would be 6.3 divided by 10, divided by 10, divided by 10, over and over again. Each time you divide 6.3 by 10, the decimal is going to move one more space to the left. So if we know that, then we can take that shortcut of scooching that decimal 10 spaces to the left, putting it at the front, and then filling all those spaces with zeros for our answer. The second example looks like this. Or with the shortcut, you're moving that decimal 7 spaces to the left, putting the point in the front, and filling the spaces with zeros for this final answer. Take a minute to try these on your own. Now let's go the opposite direction, standard form back to scientific notation. Here are the 3 questions you need to consider when doing that. If we start with this number, 12 billion, we need to decide where would I put the decimal so that my starting number is greater than or equal to 1 but less than 10. In this problem, it would have to go between the 1 and the 2. And then we need to decide how many places does it need to move to get there. Keeping in mind that in this number, the decimal starts back here, it would take us 10 spaces to get there. And since this is a very large number, this is going to be a positive power for a final answer of 1.2 times 10 to the 10th power. In this example, we would need to move the decimal all the way over to between the 4 and the 5 so that that initial number is greater than or equal to 1 but less than 10. To get it there, we're moving 12 spaces. Since my original value is a tiny, tiny decimal, that's a negative power for an answer of 4.56 times 10 to the negative 12th power. Here are a few examples for you to try. And here are a few more if you need them. For an application, there are a lot of times where we use scientific notation when computing addition, subtraction, multiplying, and dividing, depending on the values that we're working with, and you'll be experiencing this more and more as you study different sciences. If the world's population in 2025 may reach 7.84 times 10 to the 9th power people, this is about 3 times what the population was in 1950. What was the world population in 1950? This means we need to take our estimate for 2025 and divide it by 3. The only value you're actually dividing by 3 is that leading number, 7.84. And when you do that, you get 2.613 times 10 to the 9th power. See me if you have any additional questions or for help.